Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. As you used to know that we used to update on biological lessons, today I want us to look at a chapter in chemistry, most probably chemistry form 2, the first chapter. Now, in the first chapter of chemistry form 2, sometimes it lay basis for the chemistry that comes after it, the chemistry knowledge that comes after it, that is the topics that come next after the first topic. And therefore, understanding the first topic in chemistry form 2 is very important, as it lay basis or rather foundation for the other chemistry that lay ahead for the learner to understand it better. Now, as you can see here, we have the structure of the atom and the periodic table. Now, the first thing I want us to look today is, we need to look at the structure of the atom. After looking at the structure of the atom, we're going to see the periodic table. And another thing to add on, I'll not be doing the way normally the teachers do in class, because if I do that, it may become boredom. Sometimes I may rush over it, capturing the important areas that needs to be clarified, and the students at times find it difficult to comprehend. Structure of the atom and the periodic table. Let's look at the atom, first part of let's look at atom structurally. Structure of the atom. Structurally, an atom is composed of the central part, that is the nucleus, central part. That is the nucleus. You also have the larger outer part, the larger outer part. That is the energy levels. Structurally, an atom has the central part, that is the nucleus, and the larger outer part surrounding the nucleus, that is called the energy levels. Good. Now, again, what is this atom made of? We say atom is basically made up of subatomic particles. Very important point to note. Atom is made up of subatomic particles, made up of subatomic particles. And we say an atom is structurally, it has the central part and the larger outer part surrounding the central part, that is the nucleus and the energy level. And we have, within that structure, we have subatomic particles. Those are the three. We have protons, neutrons, and electrons. Protons are positively charged. Neutrons, they have no charge, while electrons are negatively charged. This is how they are distinguished. Now, let's look the location of these subatomic particles and the structure of the atom. As you know, the atom basically composed of the central part, that is the nucleus, and the larger outer part, that is the energy level. Now, let's look at the location of these subatomic particles in the structure of an atom. Now, if I sketch a rough structure of the atom, an atom simply looks like this. This is the structure of an atom, for instance, just a rough sketch. Now, this is the nucleus. Now, as you can see, in the structure of an atom, we have this nucleus, and we also have the outer part surrounding the nucleus, that is called the energy levels. The energy level. And again, another important thing that you need to understand is the location of these subatomic particles. Now, in the nucleus of an atom, we have protons. We also have neutrons. Good. And again, on the other side, we have the energy level. In the energy level, we have the electrons. this is now the structure of an atom, the central part, large outer part, the subatomic particles, and the location of the subatomic particles and their charge. Another important question that most of the Malanas are at times asked is, why is an atom said to be electrically neutral? An atom is said to be electrically neutral. Why? Simply because the number of protons and the number of electrons in any given atom of an element are equal. And therefore, for instance, let's take an element like sodium. Sodium has 11 protons and it has 11 electrons. That means we have 11 positive and 11 negative. And what happens is, if 11 positive and 11 negative are added, we will be having a 0. And therefore, that is why it's said to be electrically neutral. Simply because the number of protons equals to the number of electrons. And having in mind that these two subatomic particles do possess different charges, as in the case of protons have positive charge and in the case of electrons have negative charge, and their number is again similar, that now tells us why an atom is said to be electrically neutral. And therefore, the structure of an atom, this is basically the thing that you need to master. And the question that you can be asked is, why is an atom said to be electrically neutral? Describe the structure of an atom. What are the composition of atom? That is the subatomic particles. Another most importantly is, these two protons and neutrons which are found in the nucleus of an atom are called nucleons. Sometimes you can be asked, state the reason why protons and neutrons are said to be nucleons. This is because they are found in the nucleus of an atom, in the structure of an atom. That aside, that is now complete. Now let's look at the second part, that is the periodic table. The periodic table. In chemistry, the elements that we will be learning in the periodic table are the first 20 elements. The first 20 elements are what we are going to deal with at this level. And therefore, we need to understand these first 20 elements. Number one, the atomic number, electrons, protons, neutrons, mass number, valence, valency, group, period, as well their oxidation number. And if I just have their chemical symbols just here, so that we can discuss more about them, is, for example, we have the first element as hydrogen. We also have helium symbol. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. And this class are the first 20 elements in the periodic table, and therefore this is their chemical symbol. The chemical symbol of the first 20 elements in the periodic table. And therefore, when indicating the atomic number, the AN, atomic number, that's our symbol, the AN. Let's look at the AN. The atomic number is very simple. The atomic number basically is the number of protons in the nucleus of an atom. And therefore, in simpler terms, the way they follow in that order from hydrogen to calcium up to number 20, that order, that is from number 1 to number 20. In other words, in a simpler way, you can know that order from number 1 to number 20 is that we refer to as that atomic number. But when defining atomic number, you say the number of protons in the nucleus of an atom, in the nucleus of an atom of an element. Very good. Now this one has atomic number 1, atomic number 2, number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is the atomic number of these elements. Very good. Now, I may not write the electrons and the protons, but what I will do is I'll tell you what the electrons and the protons are again. The electrons and the protons, they are similar to the atomic number, but the only difference is the atomic number does not have any charge. We don't say it's just a number. But when it comes to electrons, exactly the way we are doing this 1 to 20, but it has that negativity. It possesses the negative charge. For the case of protons, exactly similar to the atomic number, but it do possess a positive charge. And therefore, atomic number, electrons, protons, they have the same, they correspond when it comes to the numbers, directly corresponding when it comes to the numbers, but they are different in a way that the atomic number is just the numbers from 1 to 20, while electrons do possess the negative charge, while the protons do possess the positive charge. And therefore, I don't see any importance for them to write because we will just be repeating this. Another very important thing is about the electronic arrangement. The electronic arrangement of this element. The EA, electronic arrangement. The electronic arrangement. Now, when it comes to the electronic arrangement, there is a way that there is a concept that you must be having so that you be an expert in this. For instance, the first thing that you need to know is that in electronic arrangement, the first energy level carries a maximum of 2 electrons. What does that mean? The first energy level after the nucleus can hold only maximum number of electrons is 2. And therefore, if there is an additional electron, that has to develop another energy level. Very important. Subsequent ones, the second, these ones that you are learning right now, they go up to the 4 energy level. And therefore, we say, second, the subsequent carries the subsequent energy levels carries a maximum of 8 electrons. Now, it does not mean that is now the end. No, there are times they carry 18 electrons, but at this level, what you need to know is that the subsequent one that is up to the 4th energy level, or rather the 4th occupied energy level, they carry a maximum of 8 electrons, because we are not interested beyond that, because ours is limited to the 8 electrons. And therefore, it is important we be expert at every step we are before even looking what lay ahead of that, so that when that comes again, you have to be very smart again, or then to adjust your knowledge to the next levels. But for these cases, what you need to know is that the first energy level carries a maximum of 2 electrons, while the subsequent one, that is up, the subsequent ones, they carry a maximum of 8 electrons. Very good. Now, for instance, let's look at how the electronic arrangement looks like. For instance, the first element, that is hydrogen, is 1. Helium is 2. Now let's look at lithium. How will lithium look like? Lithium is having 3 electrons. And we know the first energy level carries a maximum of 2 electrons. So we are going to remain with 1 extra electron, and that one extra electron has to get another energy level. And that should be, therefore, it will be 2, 1. Now, to make it easier now, we need to understand that the trade is going to continue downwards. For instance, the last one will be 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 27, 28. Now, that is why I wanted you to again to locate. Now we have seen that again, the second energy level has reached a maximum of 8 electrons. Now we don't write 2, 9. No, we now start developing another energy level, 281. 281, 282, 283, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. Very good. Now let's look at silicon. It will be 284, phosphorus 285, sulfur 286, chlorine 287, argon it will be 288. Now we can see again the third energy level has reached a maximum of 8 electrons. Now what happens next? They develop another energy level, that is potassium. It will be 2881 and calcium it will be 2882. That is it. Now, another very important thing I want us to discuss again and dwell on is, we have something very important here that most of the learners at times they confuse, and I want to make it clear. Now, when it comes to, for instance, because we are just doing a review of the entire whenever that they are linked up, I want us to look something very important is when we are grouping them into periods and groups, what do we check? For instance, let's look at this. In chemistry, you may have heard something called valence. You may have heard valence. Valence. Now, valence is the number of electrons in the outermost energy level. Number of electrons. Number of electrons in the outermost energy level. Valence. Very good. And for instance, if you look at these valence, let's look at the valence here. Here the valence is 1, here is 2. The valence here is 1, here is 2, 3, 4, 5, 6, 7. Here is 8, here is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Now you can see this now the valence. And you say the valence is the number of electrons in the outermost energy level, of an atom of an element. Very good. Again, we have another terminology that is valency. We have another terminology called the valency. We have valency. Valency again is number of electrons an atom gains or loses during chemical reaction. Number of electrons an atom gains or loses during a chemical reaction. The number of electrons an atom gains or loses during a chemical reaction. And what you know is that metals lose electrons to form positively charged ion, and the positively charged ion is called cation. And therefore, nonmetals, they gain electrons to form negatively charged ion, that is called anion. Now let's look. For instance, an element like hydrogen, the valence, now let's look at, this was valence, let's look at the valence. Now valence here is 1, this is 2, this one is 1, this one is 2, this one is 3, this one is 4. Now, here now, it's having 5. The outermost electrons is 5. Now, what will be? Is it easier for nitrogen to lose 5 electrons or to gain 5 electrons? You say, rather than losing 5 electrons, it is easier for it to gain 3 electrons to become stable. And therefore, it has 3 electrons. This one, it has 6 electrons in the outermost energy level. It is easier to gain 2 electrons. This one, it is easier to gain 1 electron. Now, valency of neon. Now, what you know again is neon is a stable and it is in octet state, and therefore it is stable. Now we say it is what? stable, neither gains nor loses. Sodium, 1, because for sodium is a metal and therefore it has 1 electron in the outermost energy level, and therefore it is easier to lose 1 electron than to gain 7 electrons. This one is 2, 3, 4, again 5, 3, 2, 1, stable. This one, 1, 2. That is again the valence. We have learned valence. We have also learned valence. Right? Very good. Now, another important thing I also want us to understand, class, is this. Now that we have learned valence and valency, we need to understand about the periods and groups. The periods and groups. Very good. The periods and groups. So that we can be able to group this element into their groups and periods. Very good. Now, periods and group. Let's start the first one, the periods. Periods basically means the number of energy level an atom occupies. For instance, the first 2 elements in the periodic table, that is hydrogen and helium, they occupy 1 energy level, and therefore they are in period 1. Now these 2, period 1. Are you seeing now? Period 1. Now we have period 1. That is hydrogen, helium. You have hydrogen, period 1 you have hydrogen, helium. Why? Why are we saying that these 2 elements, they belong to period 1 of the periodic table? Simply because they have 1 energy level. Very good. Another important thing is, let's look at period 2. The elements you have in period 2. From lithium to neon, from lithium to neon, you can see they have 2 electrons from 2.1 to 2.8. Therefore, we say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. These ones now are in period what? Period 2 of the periodic table. Simply because they have 2 energy levels. Very good. Because they are in between 3 to 10, and therefore 3 to 10, they are in period 3 of the periodic table, and therefore we say no, they are in period 2. That is why they have 2 energy levels. Now let's look at period 3. Period 3. Now period 3 you have the following: from sodium to argon. From sodium to argon, this is period 2, this is period 3. From sodium to argon is in period 3. Very good. Now, period 3. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now, these ones are in which period? Period 3. Why? Because in period 3, they have 3 occupied energy levels. They have 1 occupied. They have 2 occupied. They have 2 occupied energy level. They have 3 occupied energy level. And lastly, period 4. Period 4. Now in period 4 we have only 2 elements, and that is potassium. You have potassium. You also have, calcium. Why are they in period 4? They have 4 occupied energy level. They have 4 occupied energy levels. Simply because they have 4 occupied energy levels, therefore they are in period 4. Again, if we can look at, lastly I want us to look at the groups, then we finish up at that particular point. Now, if you come to the part of the groups again, we have 8 groups in the periodic table, and therefore 4 groups are primarily studied, and the 4 groups studied are group 1, group 2, group 7, and group 8. And for groups, it's very simple. You just look at the outermost energy level. For instance, for hydrogen is in group 1. Why? Because it has 1 electron in the outermost energy level, right? For helium, it is stable, isn't it? It is stable. Valence. This one does not have, helium does not have a valency. It is stable. It is stable. It neither gains nor loses because it is in stable state. And therefore, again, we have lithium, group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. Again, group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, group 1, group 2. You just focus on the outermost energy level, how many electrons is holding. The number of electrons in the outermost energy level in an atom of an element tells you whether the element is in which group. For instance, an element with 2.1, let's look at this, 2.1, 2.81, 2.881. These one are in group 1, Are you see now? Another scenario, 27, 287 are in group 7. Why? Because they have 7 electrons in the outermost energy level, and therefore that contributes to the group, and I think that is very simple. And in our next lesson we will be discussing isotopes, relative atomic mass, radicals, chemical symbols, and balancing equations. Thank you very much. And I was just doing some summary. I was not doing a lesson that needs a new beginning. And I know most of the learners have already covered this topic, and I was just doing a summary. And for instance, in the case of helium, I just made a mistake. I did the valence as 2, but does not have a valency, and therefore it is stable, and therefore it is stable, does not have a valency. For an element to have valency, it has to either gain or lose an electron. Thank you very much. And if you watch other things, why not chemistry, mathematics, and biology, uploaded by teacher Muhyiddin Khalif. Thank you very much and wish you Ramadan Mubarak.